So we're going to begin today with research methods, first unit, part 1, on psychology as a science. Now, today what we're really going to talk about is how we know things, and a lot of what we're going to be discussing today comes from the work of the American philosopher Charles Peirce, who came up with this way of thinking about how we come to know anything about the world. Now, what he did is he divided the world into two ways of knowing. One is called non-empirical approaches, and the other one is called empirical approaches. And that word empirical is an important word because it has to do with the idea of experience. So when I have empirical evidence, what it means is that I have actual experience that I'm able to show you as evidence for a claim. And so certain ways that we know things are through what we call non-empirical approaches because they rely upon thought and belief. They don't rely upon experience, whereas empirical approaches, on the other hand, rely on experience. Now we can further divide each of these approaches into two sub-approaches, with the non-empirical approaches being authority and logic, and the empirical approaches being intuition or science. Now, there were a couple of other terms that Peirce used. For logic, he used the term a priori, which means basically to know something before experience. He also used the word tenacity for intuition, and empirical reasoning for science. And so we're going to talk about each of these in turn. Now, when I say that I know something by authority, what I mean is that I know something because someone, hopefully someone who is respected and well known and who understands the phenomenon in question, said that something is true. So, for instance, I could tell you, Mount Fuji is over 12,000 feet tall. Maybe I'm not an expert, but I climbed it, so I know exactly how tall it is. Or someone might tell you that ameloblastoma is a type of jaw cancer. You've probably never heard of it because it's so rare, but it is a type of jaw cancer. Also, I could tell you that the Earth revolves around the Sun. Now, that's something that's been controversial through many eons, whether the Earth revolves around the Sun or the Sun revolves around the Earth, because in both cases the same phenomena is visible. But we know now pretty much with 100% certainty that the Earth revolves around the Sun. Now, again, there are some benefits to relying upon authority. The most important of which is that you can know something without having to go through the trouble of determining its validity. Okay, so you don't have to climb Mount Fuji in order to know that it's 12,000 feet tall if I tell you I was just there. Or you don't need to look up in a book on diseases ameloblastoma because I'm telling you it's true, it's a type of jaw cancer. The problem, though, is when the drawbacks, when authority can be wrong. Two examples we have from history is back in the early 2000s when the United States invaded Iraq. The argument was that there are weapons of mass destruction in Iraq. Turns out that that was not true because the authorities were wrong. Or alternatively, when Bill Clinton said, "I did not have sexual relations with that woman," about 20 years ago, we learned later on that that was not true as well. But even with some of the other ones, like the Earth revolving around the Sun, there have been very smart people throughout the history of time, the most important being Ptolemy, who truly believed that the Sun revolved around the Earth. And he, was respected and believed for about 1,000 years of history. So just because a fact has been established for a long time doesn't mean that it's necessarily right. And finally, if you're just going by authority, there's no way of resolving disagreement among authorities. So if you have person A and person B, one person saying that the Earth is flat and the other person saying that the Earth is round, it's very hard to be able to get at what is actually true, because both people, are saying opposite things. And it's often the case that people hold very different views. Just look at politics with Republicans and Democrats. But even in scientific fields, there are many disagreements. So it's something that's part of the difficulty of relying upon things from authority. The second way of knowing something is through logic and reason. So you know something by the extension of premises known to be true. So the famous example is the syllogism, and this goes back to ancient Greece, whereas Socrates is a man, and premise 2, men are honorable, therefore Socrates is honorable. This was used by Plato and Aristotle and a bunch of arguments, but the idea is this, is that if we have a situation where A is equal to B and B is equal to C, then A is equal to C. And that's called a transitive inference. Okay, and that's the whole basis of a syllogism. Now, the benefit of using logic is that there's a certain certainty of the conclusion. You know, if it's the case that Socrates truly is a man, and if it's the case that men truly are honorable, the foregoing conclusion is that Socrates is therefore honorable. The problem, however, is that the premises can be wrong. Okay? Who's to say that Socrates was not a man? He might have been a woman. We don't know that. The idea that all men are honorable, that's, I'm sure that, most people would agree that not every man that has ever existed could be classified as being honorable. So the conclusions that you reach are only as good as the premises are true. And if the premises are wrong, your conclusions will be wrong. And that is the limitation of logic and reasoning. Now, let's move on to the empirical approaches, the ones that are based on experience. So, when we talk about intuition and common sense, what we mean is that we know something by the sense that we have and the experience that these ideas must be true. So, there's a saying in English that boys will be boys, okay? And the idea is this, is that, boys will do things like take a slingshot and break a window, or climb trees and fall and break their arm. And what we know that from looking around our neighborhoods or hearing stories or watching television where we see these things happen, and therefore it's based on experience, but it's sort of like a very informal experience. Another saying that we know is old dogs can't learn new tricks. The idea here being that it's very hard to teach someone who is kind of older and more experienced something new. And if anyone has ever tried to show an older person how to set up their VCR or DVD or computer, that's where this idea of old dogs not learning new tricks comes up. Finally, you could have an intuition that this is the Eagles' year to win. They're going to be in the Super Bowl, which, of course, I have to put yeah right, because we've been hoping that for many years. But it may be the case that you really feel that your experience with the team for this year means that it really is going to be the Eagles' year to win. Now, the benefit of intuition and common sense is that this knowledge is often shared by others. If I went to California and knocked on my friend's door who lives there, and I asked them, what do you know about boys? They might say boys will be boys, because this is knowledge that's shared and that's common and it's part of our culture. Secondly, our knowledge can be tested by experience. If it's the case that suddenly we find that, people who are more experienced, they're older, suddenly are, able to figure out how to use these machines, then maybe the idea that old dogs can't learn new tricks needs to be revised. And this knowledge is also easily accessible, that allows for fast decisions. So it is really easy to just have a pithy statement like boys will be boys. It's easy to access, and then that can make a decision on what you do in terms of protecting your window, or telling a kid to get out of a tree because you don't want them to break their arm on your property. Things like that. Now, the drawback is that your experience might be biased or just wrong. Okay? So maybe it's only your dumb old dog that can't learn new tricks. Or maybe it's only the boys in your neighborhood that are breaking windows and falling out of trees. So that your experience, if it's biased or if it's shaped or affected by external factors, it may be the case that the conclusions could be wrong. Now, finally, let's talk about science, okay, which is when we know something by empirically testing a hypothesis and using data to support our conclusions. Okay, so for instance, if we're interested in the question whether or not men or women differ in how frequently they engage in aggression, what we could do is to take a group of men and a group of women and compare the amount of times they've gotten into fights, the amount of times that they have spread rumors. We would have to sort of get at what we mean by aggression and test whether or not there's a difference between the two groups. Or, for instance, if we wanted to see if there is a difference in vocabulary size between 4 and 8-year-olds, we could get a group of 24-year-olds and a group of 28-year-olds and compare how many words they use on a daily basis. And that would be a method that would be more in line with science. And the benefits of science is that this knowledge can be shared with others. If I did a study on aggression, I could write that up as a paper and publish it in a journal, and anyone that has internet access could then read my findings and be able to share it with other people, and that's a very useful thing for knowledge. Secondly, evidence can be evaluated for validity. So if you don't believe me and think that, there really isn't a gender difference in aggression, then what you could do is that you could take your own group of men and your own group of women, and you could compare the number of aggressive acts. And that could be one way in which you could see whether or not the result is valid. Now, the drawbacks of science is that the conclusions are only as good as the data. This is the same argument that we used before with intuition, that maybe it's only the people that are around you that you studied that are, behave in a particular way. So, if you are studying groups of people that are not typical of what, most other women or men are, you might come to the wrong conclusion. Another one, which is going to plague us throughout this semester, is that knowledge is never certain. You can never entirely rule out alternative possibilities. You can only make claims for the likelihood of truth. And we'll talk more about this when we get into statistics. And the final drawback is that science is often slow. It takes a long time to do science well. And a study had been done a few years ago showing that the average amount of time between the onset of an idea and its publication in a journal is about 5 years. So it takes a long time for knowledge to get out there because there's a lot of checks and balances to make sure that the claims are valid. And that's a really important thing for maintaining science as being a useful discipline. Now, often when I talk about science, I like to sort of define it as a process. And someone once gave me this cute analogy of using Homer. So hypothesize, operationalize, measure, evaluate, and then replicate, revise, and report. Okay? And so each of these is an important step that is involved in coming up with a scientific sort of conclusion. The first, with hypothesize, is the idea that you have to come up with some kind of a guess, some kind of a notion that you have about the way in which different things in the world operate, different laws. Like, for instance, if something is thrown up into the air, it always comes back down. Now, of course, your hypothesis might be that, gravity exists and it's what causes things to not be able to stay in the air. And so you might do an experiment in which you throw a bunch of things up in the air and see whether or not they come back down. Now, the second step here with operationalization is the idea that you have to define the objects of your study. So when we operationalize a variable, what we're doing is we're putting it into terms that we're able to study. So to use an example like aggression is kind of a vague topic. What aggression means is subject to debate and interpretation. And so what you need to do is to operationalize, is to define what you mean by aggression. So you could define aggression by the number of fights that someone has gotten in their life. Or you can define aggression as the number of times on a scale of 1 to 10 that someone answers how aggressive they are. And that's what we mean by operationalization, is that we put things into terms that we're able to measure and study. The third one is measurement. Science is all about measuring things. What we do in doing a study on vocabulary size is that we're interested, is there a difference between the size of the vocabulary of your average 4-year-old and your average 8-year-old? So we go out and we measure their vocabulary. Now, of course, there's many ways that you might do this. You could videotape a kid for 3 hours and measure the number of unique words that the child says, or you could give a checklist to a parent in order to check off how many words that they've heard the child do. There's lots of ways in which you can come up with data and measure things. That can be a great thing, but it also can be a problem because sometimes different ways of measuring things come up with different conclusions. So that can be a problem with measurement. Finally, evaluate. It's important to be able to evaluate claims, and in order to do that, we use statistics. Now, of course, many of you have probably already taken statistics. We're going to go over statistics in a unit in this course, but it's very important to be able to use statistics to be able to evaluate claims. For instance, if I do have a group of men and a group of women, and I have the average number of fights that women have gotten in, and the average number of fights that men got in, how do I know that that difference is big enough so that I can say that it's not just due to chance? It's not just because I happen to select a couple of more aggressive males than women. How do I know, and how can I make inferences about the population of all human beings based on the sample of 20 men and 20 women that I actually studied? And that's all part of the evaluation process. And finally, replicate, revise, and report. Replication is a really important term these days in psychology because psychology has gone through what we call a replication crisis, where a lot of classic findings that we've traditionally thought were true turn out in the end to be a little bit less solid than we thought. So when we replicate, what we do is we do a study a second time. And hopefully what we find the second time that we do it is we find the same exact answer as we did the first time. And that's the idea of replication, is that when you do a study multiple times, do you come up with the same answer? And so that's going to be something we're going to discuss at greater length. And then secondly, revise and report. It's really important if we're doing science to get it out there to the world so that the world can figure out what we're doing. And so that's, a lot of what writing is revising what you wrote to get it to be the perfect statement of what you found. And finally, reporting is to get it out into a journal, because that's a very important factor and feature of all of this, is to be able to publish your results so that people know what you did. It's great to do science, but science in a vacuum doesn't really help anyone. Now, it's important to know that there are many forms of science. Okay, social science, biological science, physical science, each of which has its own unique characteristics, its own what we call paradigms or way of studying things. And so science is a really broad phenomenon. It's a broad skill set that I think can really be applied in almost any setting. So whether it be work or personal life, one can adopt a scientific approach in order to understand the phenomena that surrounds them in a better way. And so I often say to students, you don't need to be wearing a white lab coat or zap rats to be a scientist. You can apply what you're learning in this course to problems that you face in everyday life, and in many ways you can come up with better results if you do this.